by the bias is on the crystallography axis only. That is the first crystal system. Isometric is isometric or cubic system. Yeah, I will take the one whiteboard. In this crystal system, there is a three. These are all angle between these crystals. Angle between these three lines. 1, 2, 3, right? So there is a is equals to B is equals to C. A is equals to B is equals to C. Nothing but alpha, beta, gamma is an angle ratio. AB is a axis. Equal length. These axes are all are in equal length. Where it is having the equal length, they are called as a A1, A2, A3. You see here A1, A2, A3. These three axes are interchangeable. Is interchangeable, like it's crossing this area, is crossing like this, is crossing between intersection. The A1 axis front to back axis. Front to back axis, A2 is a side to side, A3 also vertical. So vertical, like a horizontal. You can call it side to side, nothing more. You can call it the horizontal axis also. Now, these unity and axial angles are equal. These three angles are equal, 90 degrees. Is axial elements crystal belongs to same this system, isometric system, whereas the three angles are having the same length and same angle between the axes is called the isometric or cubic system. Whereas I come to the tetragonal system, there's a tetragonal system. There are three axes. The same like this. There are three axes, and which two are equal length. Two are equal length. Length is equal and the horizontal, but both are the right angles to each other. The third one is vertical. This is a vertical line. You are seeing, right? See, vertical line, and it is made shorter, sometimes it's longer. These two are the same length, but C comes to shorter or longer. That's the horizontal axis. Like A1 is equals to A2. You can see here, A1 is equals to A2, nothing but A1, this is A1, this is A2, and C is not equal to C. These two are same, C is different. Whereas the angle is same, length is different. Okay, A alpha, beta, gamma, is angle between the three axes is a 90 degrees. This is a calling the, whereas a two axis length is the same, one is a shorter or bigger than the two axes is calling as a, whereas a angle is same. This system is called as a tetragonal system. Now come to the orthorhombic system. Whereas the orthorhombic system, three crystallograph axes are different length. You given the mistake here, just reminded. Orthorhombic system is also not equal. I think this one. Sorry. Yeah, I don't know. Yeah, This is an orthorhombic system. A is not equals to B is not equals to C. Means three axes are not the same length, but angle is same. The between the three angles is same. Is a mistake. Is a printing mistake is there. Just cross it. Okay, A is not equals to B, not equals to C. There is a no angle. Sorry, there is a no length same. Whereas a alpha, beta, gamma, three angles of 90 degrees, that is equal, which is called the orthorhombic system. These three lines, A, B, C, these three lines are unequal. Angle is same. Come to the monoclinic system. All three crystal axes have different length, like the tetragonal, like orthorhombic system. These three crystals are different length, but come angles, whereas a alpha and gamma has the same angle, 90 degrees angle, whereas a beta is a different angle. Various, nothing but there's a different angle means various of the increase or decrease. This is calling the monoclinic system. Yeah, you can want to see the position of the B axis is fixed, and it coincides with the singular axis that lies normal to the A and C. It's a line and C line. This B is a fixed. These two ratios, angular known, A by B. So A by B is nothing but A to B and CB. This is C line, CB. These two are same because of A crosses the intersection between the A and C, right? B and C. So here B and C angle between the same. When I come to this beta is a variance from these two angles. So this is calling the monoclinic system. But length also different. Come to the triclinic system. In the triclinic system, there are three crystallographic axes at different lengths. Crystallographic axis at different lengths and angle also different values. B is not strict, means not in the horizontal line. B also different. C also some angle, not vertical. This angle. A also angle. So here these three are not in the same line, same length, as well as these three angles are having the different angles. It is called the triclinic system. Whereas come to the hexagonal system, in the hexagonal system, three out of four crystallographic. There is a three, 1, 2, 3, but 1, 2, 3, right? Are horizontal plane and are equal in length. They are called as A1, A2, A3 axis and make angles of 60 or 120 degrees. Various. So various degrees. Like four axes of which three are in the horizontal, three are in the horizontal plane, which are mutually inclined at 60 degrees, but the angle between their positive and ends in 120 degrees. See, ends with 120 degrees, but mutually there is 60 degrees. 1, 2, 3. These are 60 degrees in mutually, but ends with the 120 degrees. From here to there, from here to this to this. This is 1, 2. So 1, 2, 3. But four crystallographic axes. So for this reason, there is a mutually 60 degrees and overall 120 degrees angle. It is called as a hexagonal system. So, and come to the classes. In these all crystallographic systems based on the axis, based on the length, divided into 6 major crystallographic systems. So here, they in these systems having the number of classes. There is a number of classes in between the systems. By based on the classes are classification of crystals into classes depends upon the degree and nature of the elements of symmetry. Degree and nature of elements of symmetry. It has shown, you can see that mathematically you can show in that one. And there is a only 31 combination of symmetry elements are possible. Total 6 major crystallographic symmetry. In this, there is a 31 symmetric classes are there. And there is a 32 crystal classes. 31 crystal symmetry without any 31 crystal symmetry, and is a 32 crystal classes. All of these 32 classes are grouped under the 6 crystallographic systems. Whereas a triclinic, isometric or cubic system, there's a tetragonal system. Isometric having a number of, there's a 5 classes. Isometric having the 5 classes, and tetragonal having the 7 classes. Hexagonal having the 7 plus 5. Like hexagonal, there's a 2 divisions: hexagonal division, trigonal division. And orthorhombic having a orthorhombic system having the number of 3 classes. Monoclinic system 3 classes. Trigonal system 3 classes. There are classes I mentioned here, I think so. This hexagonal system figure it here. This is a hexagonal system. One is a rhombohedral, another is a trigonal. These 2 types are there. There's 7 classes. One is a 5 classes. This is a trigonal is a 5 classes. This is 7 classes. But how the number of classes are divided based on the characteristic of symmetry elements. Whereas a 4 axis of 3-fold symmetry, isometric symmetry having the 4 axes of 3-fold symmetry, whereas tetragonal is a unique 4-fold axis. Or don't confuse here, because of you can talk about only axis with symmetry classes. If you know the classes face, how the faces, based on the faces, based on the axis only faces are created, right? Which is the face is looking, you're observing the face crystal. You can naming that crystal naming based on the classes. Each and every system, the class which shows the highest degree of symmetry. Highest degree of symmetry is known as a holohedral or normal class. When you see the highest degree of crystals, if in case example, highest degree of symmetry, highest degree of symmetry, if you see in the crystal, we can call as a normal class or holohedral class. There are the different classes. Designed as hemihedral, hemiomorphic, enantiomorphic, or tetrahedral classes. See, okay, we're coming to this one. We study crystallography. Crystals is known as a crystallography. Crystallography is nothing but you can study about this one. We're studying. So crystals, we're studying about the crystals. The space is a matter, or otherwise called as substance. Where the substance between the spaces, this angle, how much space will be there, how much angle of the between the axes. Whereas a gaseous, liquids, and solid states. While creating this, when crystal creating gases, liquids, what is it? where is any gaps are occurred when you go into solid state, crystals are going to solid state. What is the gap is occurred? How the elements are, how the elements and the protons will be, come to the one places. Another one is how the taking. If in case is formed in the is bonding, it divide the bonding level uh, and the axis of the crystal elements. When if solid substance is bounded by naturally formed faces, it is called a crystalline. The crystalline nature of solid cannot be established any other method by any known methods. Like a amorphous is a homogeneous, anisotropic, and solid. It's characterized by the different chemical composition. Defines chemical composition. Same chemical composition having the anisotropy solid. When you're calling about the crystals, crystallographies, we can how in the laboratory we can divide as a based on the crystals are faces of the crystal, edges of the crystals, corners of the crystals, center of the crystal, axis of the crystal, planes of the crystals, and zones, interfacial angles between the crystal axis. There you can see there are 360 degrees. Occupy the same position. See, same position, space more than once in a complete rotation of 360 degrees. A crystal has a center of symmetry when it's like a faces, edges, corners are arranged in pairs and regular positions opposite sides of the central band. Observe this image. You can observe this all images. How this forming is a horizontal axis in hexagonal system, right? How the system crystals are forming. When you if you see the about diamond is a graphite. Um, there are so many examples of there is a minerals crystal minerals are there. For your galena and the hollow galena type is nothing which comes to um, the normal class. We call it normal class. Galena is a normal class. There is a one example of that minerals. Is a crystal systems are nothing but minerals of minerals. How the minerals are formed as a solid state. Is an example of this crystallized the system. Galena type you can call morphic porphyritic type, and the mica is the mica is a mica is also there. Mica system you can call a mica system is a big crystalline system. Okay, come now we are going. We will discuss about each and every system individually. Isometric system, how the features. For example, you can talk about the isometric system. When all exercise and everything, we can isometric, tetragonal, and orthorhombic system. We can talk about this in the unit 2, covering it here. So in earlier unit, crystals are there is 6 systems already we discussed. 6 systems. Each systems have the 32 based on the axis. Based on the length. Systems are divided. So coming to the isometric system is nothing but a cubic system. Is singular is divided of a singular axis and 3 crystallographic axes of equal length. There's an equal length and equal angle. Equal length and equal angle called as a isometric or cubic system. These systems have the 5 classes. The isometric system having the 5 classes. based on the how the classes are divided. Based on the crystal class, called as the crystal classes, based on the nature of the elements of symmetry. Elements of symmetry. These are see here. Observe the planes of normal. These axes are called the axial planes. These crystals have a invariable four-triad axis or inversion triad symmetry. This symmetry is called as tessellal symmetry. All the crystals formed in the system are closed forms. There is a you can call as a cube. Cube is nothing but it's a closed formation. You see the cube, right? When you see observing the cube, it's a closed formation. There is no space in outside. You can the closed direction. What is a feature? If in case these are unique features of isometric system. Isometric system has unique features like ratios are 1:1:1. This is a ratio for the isometric system 1:1:1, and classes has a 4-axis, 3-fold symmetry. And this is a closed form. And it can exist as a real crystal. See, observe here. It's a closed form. There is a 4-axis, 3-fold symmetry. 4-axis. There is a 4-axis will come in this one. 3-fold symmetry. Example, galena. Galena type. Galena is a principal mineral belonging to this class. Is a one more thing, isometric is a composed of classes containing more than one axis of n-fold symmetry, where n greater than 2. Is the important features of the isometric. How to identify the isometric system? One is a 1:1:1 ratio, and there is a 4-axis of 3-fold symmetry. Is a closed form and therefore can exist in real crystal. It forms like a pinoid, pidion, and pinacoid. In its system, it forms like a pinoid and pinacoid, and a system composed of classes containing more than one axis of n-fold symmetry. N-fold symmetry, n is number of folds. There is so many number of folds in the symmetry, whereas n is greater than 2. You can write the numbering. The symmetry diagram of direction of inversion classes. There is a classes include the system, tetrahedral classes. Tetrahedral axis you can mention here. It's a tetrahedral classes, diploidal or pyrohedral classes, tetrahedral classes, normal. This is a normal classes you mentioned. Cube. This is a cube formation. Cube octahedron is given the mentioned dodecahedron, tetrahexahedron, as we discussed. These are all example of the isometric. These are example of the isometric. These are minerals. So come to the point. In this is a 4-axis 3-fold symmetry. 4-axis 3-fold symmetry. 6:1 is nothing but elements are like this. Symbols we can call the symbols. There's a cube. Cube has 6 faces. 1, 2, 3, 4, 5, 6. Up. There's a left and right. Up and down. Front and back. Okay. 6 faces. It otherwise called as a hexahedron. The faces are square shaped. You can see, observe, this is a square shaped. And the Miller symbol of the form, you can see, observe here, 1, 2, 3. These are three angles. Three are the same length. That's why called as a squared. Because of already is divided same length. Symbol of form is you can is a 100 is important point. 10 if one what is the form of isometric Miller symbol is 100 is a isometric symbol. Miller symbol. Miller is a scientist name. So here this is called as a Miller name. This Miller indices only. The three axes passing through the center of the faces of the form are called cubic axes. These axes coincide with the crystallographic axis and show tetrahedral symmetry. So entire normal classes having the 9 planes of symmetry, 13 axes of symmetry. Whereas coming to 9 planes of symmetry, 3 axial planes, 6 diagonal planes. Like a 3 axis fourfold, 3 axis fourfold, 4 axis threefold, 6 axis twofold. See, 6 axis twofold. Based on the symmetry. This is center of symmetry cube we discussed. Number of faces 6. Symbol is a 100. Come to the octahedron. This is octahedron. This is octahedron image. Number of face 8. 1, 2, 3. When you octahedron is nothing but like a rhombus. Octahedron having the 8 faces. You can Miller symbol is a 1, 1, 1. Miller, whereas a Miller symbol come to the 1, 1, 1. Cube Miller symbol is a 100. Octahedron Miller symbol is a 1, 1, 1. This is having the 8 faces. Dodecahedron, it is a 12 faces. Its Miller symbol is 100. Sorry, 110. 1, 2, 3, 4, 5, 6, 7. We're not able to find out the figure in this image. If you have that, if you are seeing the real image, you can easily calculate the number of faces. How the system having the how the crystal having the faces, the smooth face or rough faces. How this is shaped, the Rambo face or the number of how many faces are exactly is there. How many where did it process the see here, the 6 axes passing through the center of the face. From this face, center of the image, how many faces are passing? This is the face of this form are called a dodecahedral axis. Where the tetrahedral axis, 24 faces. It contains 24 faces. Is a 210 symbol. H is greater than K. HKO. These faces of this form lie in the zone containing cubic and dodecahedral faces. 24 faces. If you see, 1, 2, 3, 4. 4. One side is a 4. Whereas a 24 faces nothing but how many faces are? 6 sides, 6 faces are there. 6 sides are there. Each side have the 4 faces. The forms look it 4 faces are arranged on the each of the 6 cubic faces. It is a one face like this is there 6 cubic faces are there. Each face is contains the 4 faces. So totally 24 faces. Tetrahexahedron having the 24 faces. Whereas a Miller symbol comes to the 210. In the tetrahedron, there is a trapezohedron, or you can call the tetragonal disoctahedron. Yeah, disoctahedron, trigonal disoctahedron. Just a minute. Sorry for interruption. Yeah. There's a tetrahedron has a 24 faces. Each face like a cubic faces. There's 6 faces are there. There is another is there. The same 24 faces having. It's also trisectohedron. It is also called as a trigonal trisectohedron. It occurs along crystal faces, has the shape of isoclase triangles. It is like this. This is so many triangles is there. Miller symbol is a 2, 2, 1. As divide is a Miller symbol 2, 2, 1. The faces of this form lie in the zone containing octahedron and dodecahedron. Same like a tetrahexahedron having 24 faces and trisectahedron having the same 24 faces. And this is also same isotonic tetrahedron. Isotonic tetrahedron or trapezohedron. We call as a trapezohedron. Having the 24 faces. But mineral symbol is formed as HLL, where H greater than 1, like a 2, 1, 1. Greater than 1 means LL is less than H. Is a one of such a form. Face of form lie in the zone containing cube and octahedron. See this time rotation. Can I rotate it? Yeah, although you have the books here, so just to see. Okay. These are all minerals of the minerals. These are all minerals are example of the isometric. One is a galena. Sorry, this is a PBS in this, but this is a code chemical name PBS. Lead and so galena chemical composition PBS and highlighted chemical composition NaCl, sodium chloride like periclase, albendite, fluoride. CAF2 is like side PBS, NaCl. These are all chemical composition of the mineral. This mineral forming with this chemical, these two, lead and sulfur, like NaS, sodium and chloride, MnS, manganese and sulfur. I think M2, magnesium oxide. This is one oxygen. There is a 4 oxygen, spinel. These are diamond, so copper. Diamond is a cubic system because it's cold. It's a closed form. If you cut the diamond, you see the closest form. There is no open forms. You are not able to see. Copper, gold, diamond, almond iron. There is a garnets are there. Almond and other garnets. These are all the example of the isometric or cubic system. These are minerals. These are chemical formation, chemical composition of the minerals. With these chemical elements only, minerals are formed. When I come to the tetragonal system, just zoom in. I'm not able to rotate here, but I don't have the access for this. Yeah, okay. There is a complete tetragonal system. In this system are characterized by having the only one singular axis. It's having the only one singular axis. There are the 7 symmetric classes having this tetragonal system. In the seven, one is a normal class having the ditetragonal dipyramidal class or zircon type. We can call it zircon type. Gallium type comes into the cubic system. Zircon type comes under the tetragonal system. It's a tetragonal trapezohedral class of trapezohedral class called as a trapezohedral class and ditetragonal pyramidal or hemimorphic class. And there is a tetragonal dipyramidal or tripyramidal class, tetragonal scalendrohedral class or spinoidal class. Like this, there are 7 classes into the tetragonal system. Come to the normal class. These 7 classes system there: tetragonal inversion classes, tetragonal inversion class, tetragonal polar class, tetragonal holoaxis class. There's a different names also there. There's a degree each level, so that's why he mentioned like this name. In the PG level, you can talk about the uh, individual classes, how the mineral indices, how the minerals are forming. When you see into the microscopic, polar microscopic, you can observe the mineral indices. Based on the mineral indices only, you can identify the crystal name. These are mineral names. Based on the crystal axis and crystal numbering, how the twinning, how the minerals is twinning, how the minerals have in the lighting, how the different colors are shaded. There is a how many faces are able to see physical properties and microscopic observation. Then we can observe the based on the observation. You can write the mineral name and how which system the mineral contain. Sorry, this is normal class or ditetragonal equilateral class or normal class or zircon type. These 3 are same. This is a 5 planes of symmetry. It's a symmetric lemmas with planes. 5 planes of symmetry. 3 is axial and 2 is a diagonal. There is a 4 vertical actually. There is a 4 vertical, 1 horizontal. Okay. In the 4 horizontal, 2 diagonal and 2 axial. 1 horizontal plane. And other 5 axes. 1, 2, 3, 4, 5. These 5 axes, 1 center of symmetry. So 5 axis is the 1 4-fold axis, 4 2-fold axis. In this, 2 are axial and 2 are diagonal. 2 dial axis is axial. Axis is normal to symmetry plane. Axis is normal to a symmetry plane. But here, 2 axial, 2 diagonal. 1 is a 4-fold axis. 1 is a center of axis. Center of symmetry is only 1. See the symmetry diagram of this normal class or zircon type, where is a number of faces, basal pinacoid. Come to the basal pinacoid, there is a 2 faces. It has an open form, millimeters 001. And you can come to the It's a tetragonal prism. First order, this is second order. First order having the 4 faces, but Mendel indices is different. 110, whereas a 2 prism, Mendel indices is nothing but face are 4, but Mendel indices is Mendel symbol is 100. Ditetragonal prism is 8 faces. This Miller symbol of the form is HKO, where H greater than K. Don't think about the H greater than K and 210, but you can, if you know that the Miller symbol HKO for belongs to ditetragonal prism having the 8 faces, it is in the tetragonal system. Tetragonal bipyramid is the first one. Tetragonal bipyramid second order. The first order, second order. There is orders. Both have the 8 faces. Both are the closure forms. Shape of shape of the isoclase triangles. Both are the same shape, same faces, and same forming. But the Miller symbol is HOL. This Miller symbol is HHL, where H and L has a no specific relationship. Like 111 is a Miller symbol of the one of these forms. We come to this bipyramidal second order. One of the horizontal crystallographic axis lies parallel to the faces of the form, depending upon the choice of horizontal. If you are come to the laboratory in our crystallographic lab, you can observe that the crystals. There are crystals are there. How the axis has how the center of how the axes are going, what is the symmetry, what is the angle, how can you calculate this angle, how can you see the faces. Then based on that, which you observe the crystals and the face with the megascopic, easily you can identify what is the order, how can you classify the names, systems names and faces names, and these Miller numbers. These Miller numbers come is having the mathematical formula. And come to the ditetragonal bipyramid, has 16 faces. Ditetragonal pyramid class having the 16 faces is also closed form. It's an isoclase triangle. Miller symbol is HKL. Miller symbol is HKL. So there are example of minerals of this elements. Rutile is a chemical formation TiO2, anatase, caesartite, pyrolusite, osmanite, calomel, zircon. This is a zircon type. Remember it. Zircon type is a tetragonal system, and cubic system is a Galeno type. Bismuthite or hydrocrase. These are chemical formula of the minerals. In the tetragonal bipyramid class, there is a one plane of symmetry horizontal. There is another one axis of four-fold symmetry vertical. And center of symmetry present. There is a third order tetragonal prism, third order tetragonal prism, bipyramidal third order. Having the 4 faces, we not here will not you are observed, but there is a tetragonal bipyramidal having the third also there and third bipyramidal also there. The third bipyramidal having the 4 faces comes to tetragonal bipyramidal third order having the 5 faces, but Mendel symbol is different. There is another tetragonal pyramidal class. This is a tetragonal pyramidal class is 1, 2, right? One is a pidion, another one tetragonal prism, tetragonal pyramid. Prism is a pyramid. In the tetragonal having a prism 1, 2, 3 basal pinacoid. There is a formation of these all elements is a basic level. This one come to if you studying in the deep level, they can divide into these many different systems based on the symmetrics, based on the faces, based on the number of center of symmetry, angle, vertical axis or uh, vertical axis or horizontal axis, as well as we can call about the symmetric number of symmetries. We can divide these tetragonal pyramid classes. All the classes divide based on this one. These are all example minerals of the tetragonal system. Come to the orthorhombic system. Yeah, orthorhombic system is not you discussed earlier. It is a orient a crystal of system in such way that B axis is greater than A axis. There is a divergence of opinion regarding the relevant length. Length is different, okay, of the C axis. Okay. Come to this. There are three symmetric classes in the system as follows. The orthorhombic system follows the three classes, system classes. One is a normal class. This is a normal class, or we can call as a orthorhombic dipyramidal class. But here, you can see bipyramidal class, orthorhombic pyramid class, orthorhombic dispyramidal class. There is a naming difference is here. You mentioned the diagonal equation class, equatorial class, diagonal holoaxial class, diagonal polar class. Is a normal class. Is orthorhombic bipyramidal class. Is orthorhombic dispodial class. These are different name of the same classes. This is a Barrett type. Cube is a Gallner type. Tetrahedron is a zircon type. This is a Barrett type. You can call as any of this. There is a normal class having the plane of symmetry is 3 axial planes of symmetry. 3 axial planes. Axis of symmetry is a 3 axes of twofold symmetry. The 3 axis twofold symmetry. One diode axis normal symmetry, normal symmetry, normal symmetry. Center of symmetry present. One center of symmetry also there in this orthorhombic system. The Hermann-Magnian symbol is 2m, 2 by m, 2 by m, 2 by m. Mentioned here shows a symmetry diagram of the class. Coming to the basal pinacoid, forms presents. The forms of the classes are described below. Based on the forms, they divide in the different classes. Forms divide the classes. These classes like a basal pinacoid. Basal pinacoid has 2 number of faces. 001 is a symbol, Miller symbol. It's a lie normal to C axis and parallel to A and B axis. Basal pinacoidal, side pinacoidal, front pinacoidal, rhombic prism first order, rhombic brachychrome. And as you can see, observe the number of faces. There's a brachypinacoid, macropinacoid. There's a different names. Front pinacoid is nothing but macropinacoid, and side pinacoid is a brachypinacoid. And the rhomboidic prism first order is a there is a prism. There is a 2 there. One is a brachydome, macrodome again, and bipyramidal. rhombic bipyramid. It has the 8 faces, SKL symbol. There is a 4 faces, HOL symbol, HKO symbol. Sorry. There is a orthorhombic pyramid classes, 2 planes of symmetry, 1 axis of two-fold symmetry, no center of symmetries. This is second class. Come to the second class. You can see this class. First class has the 1 center of symmetry, 3 axes of symmetry, 3 planes of symmetry. Come to the second class. This is a orthorhombic pyramid classes or diagonal holoaxial class. It contains 2 planes of symmetry, 1 axis of one is a two planes of symmetry, 1 axis of two-fold symmetry. There is no center of symmetry. Here mention figure. No, this is not described. It's not described individually, but okay. I'm telling this one. 2 planes of symmetry, 1 axis of two-fold symmetry. There is no center of symmetry. You can call as a brachipinacoid or micropinacoid. This you can see micropinacoid and brachipinacoid is there, right? These prisms are occurring in these classes. These two are consumed in these classes. Microdome, brachydome, and pyramids represented by the half of the number of faces or corresponding forms of the normal classes. The corresponding form. But come to this third one, orthorhombic dispoidal class or diagonal polar class. There is no planes of symmetry, but 3 axes of two-fold symmetry, no center of symmetry. This consists of 4 faces, which the symbol is HKL. There the minerals comes to this orthorhombic system: sulfur, marcasite, chalcocite, stibnite, brochite, barytes, Bs for barium sulfate, TiO2 titanium, oxygen, Sb2 stibnite, is a sulfur numbers, silmonite, andalusite, geosite, hypocene, starolite, topaz. Topaz number is 9 number of the hardness scale. Codylite, aragonite, CaCO3, calcium carbonate. This is simple. These 3 symmetry comes into the. These are all minerals comes into the and the same like a orthorhombic system. These minerals contain the orthorhombic system in nothing but it has the same features like number of symmetry based on number of symmetry. There's a planes of symmetry, axis of symmetry, center of symmetry. How the minerals having with the naming of the minerals divided as a orthorhombic minerals. The summary of this isometric tetragonal orthorhombic systems. Isometric called as a cubic system. Also crystallographic are equal lengths. Angle is the same angle. We discussed already these things about how the based on the angles divided systems. For one time, just I'm reviewing this one. Isometric system. Isometric or cubic system has the same length of having the equal length axis and there is a angle also same. Come to the tetragonal system, two are the same length but two are the same length and same angle. Come to the orthorhombic system, all are different angles and length. Sorry, angles are same, length is different. Whereas come to the orthorhombic system, length is different, but angle is same. Isometric having the 5 number of crosses is a character. Isometric character is 4 axes of 3-fold symmetry. Whereas the tetragonal is a 7 number of crosses is unique of 4-fold axis or 4-fold axis of 6-fold axis of inversion. Orthorhombic system is number of classes are 3. There is a 3 axis of 2-fold symmetry. Okay, thank you all of you, and we'll discuss tomorrow about this another 3 systems: monoclinic system, triclinic system, and hexagonal system. With these 3 systems, we can complete. We are going to finish the crystal systems. So you know there is a 6 crystal systems, major crystal systems, each having a different number of classes. Total 32 classes are there. Each classing having the number of based on the number of symmetry, based on the number of axes, center of symmetry, divide as a giving the names and with the Miller symbols. With the which Mendes comes to the systems. Like example, Galen type is a cubic system. Zircon type is a tetragonal system. Now, finally, we discuss about orthorhombic system. What is the orthorhombic system? Just orthorhombic system is a like a Barrett types. See, if you call as Barrett types or zircon type or Galen type, if you anybody ask you like that, this is the same answer of the symmetries. Okay, I'm going to stop this. Thank you all of you.